All right, so here we are with Chapter 8, Section 9, and we're doing the quadratic formula and the discriminant. We're going to solve quadratic equations by using the quadratic formula now instead of graphing and factoring. And then we're going to determine the number of solutions that a quadratic equation will have by involving this thing called the discriminant. All right. All right, so the first idea, and I kind of just referenced it, is that what we've done so far is a graphing method to solve the quadratic, a factoring method to solve the quadratic, and now we're going to use the quadratic formula. So going back to graphing, remember that the advantages is that it always works to give approximate solutions. So you can always kind of see if there are 1, 2, or no solutions. And you can quickly see the number of solutions there. So it's a great visual for your advantages. The disadvantage, however, is that you cannot always get an exact solution. I recall that we did one where we kind of had to estimate that it was halfway between, but you can't always say that that's exact. You would want to actually find the correct number. The next piece was factoring. It's a good method to try first so that you don't have to end up having to plot each of the points. It's straightforward if it's factorable, but of course that's where the disadvantage comes in. It's complicated if the equation is not easily factorable, and not all quadratic equations are in fact factorable. And so because not all are factorable, that means that you do want this method, which is this one, that ends up working every single time. All right. So the disadvantages of what we're going to do today is that other methods may be easier and less time consuming, but this one will work every time. So as long as you put the time in, it will get you the answer every time. In this first box, our advantages is that it always works. And it can always find the exact solutions. So if you have like a coordinate of 2.3048, 0 as your intercept, it will be able to find that exact number versus the disadvantage over here of maybe only being able to estimate that it's 2 point something. All right, so that's our last method that we're doing today. Here's the quadratic formula itself. It is the only method, again, that can solve any quadratic equation. So it is the only. And it's the only method that can be used to solve any quadratic. Remember that quadratics have something with a square, and so we're looking for things that are in the form of a function that has an a right here, a b right here next to the x, and a c as the constant added at the end. And so once you can identify each of this a, b, and c value, so notice they're all on the same side of the equal sign, then the solutions are this super lovely formula. This formula gets pretty intense, which is why we end up having a song for it. So I'll sing that for you in a second. But what you're looking for is the opposite of the b value, whatever it happens to be. And then because we could have 2 solutions, we're going to add this top part, and then we're also going to subtract that top part to get those 2 solutions. So we will add and subtract eventually. And what you'll add and subtract is taking the b that you'll square. And from that squared, you'll subtract 4 times a times c. And then all of that in the end will be divided by 2 times a. So for this formula, we do have a song. It goes to Pop Goes the Weasel. Very exciting moment. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so every single time that I write that down, I will in fact sing that song. Pretty much every school does that. So yeah, you will have that referenced at some point. All right. So what we're going to do before I flip the page here is notice that these are the x's, because remember that the idea is that you have 2 y values of 0 because we're intercepting the x-axis. And so your two answers are going to go into these endpoints here. All right. So first thing that we look at here when we're trying to use the quadratic formula to solve is identifying the a, the b, and the c. So remember, as we wrote this earlier, we had ax squared plus bx plus c, and that equaled our f of x. And so that means that our a value is 6, our b value is 5, and our c value is supposed to be plus, so that means that it's -4 for our c value. And so now we get to plug each of these things into the quadratic equation. So going back to our super duper song, here we go. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so then we're going to plug in each of these pieces. So anytime I see a B, I'm going to put a 5. Anytime I see an A, it's a 6. And anytime I see a C, it's a -4. So officially, the only thing that we're going to plug in is right here for that B. We're also going to plug the B in here that we will square. We'll plug in the A here and the C here. And then all of that will be divided by 2 times the A value. So plugging in each of those pieces, this first piece here is going to have a 6 because it used to be a B. There's another 6 here from that B. Oh, sorry, B is 5. Hi. All right, so B's are 5, and there are no other B's. Okay, and then the A is 6, so that's going to go next to the 4 right here, and down below right here. And then the C is -4. All right, so in order to solve this, we've got a lot of things going on, but we are going to use the order of operations, so Pemdas. So when you take a look at that, that does mean parentheses first and exponents. And so if we look inside here, technically this entire radical here, the square root is a parenthesis. So we're actually looking for this thing underneath to be solved first. So the first thing I'm actually going to be solving is what is 5 squared minus 4 times 6 times -4. So all that stuff that's under the square root is what we're going to solve first. So in order to do that, we're going to take 5 squared, which is 25. And then we're going to take -4 times 6 times -4. You could do it other ways, but the idea is that there are 2 negatives here. So we'll end up adding 4 times 6 times 4. So I believe that's 96, but let's double check. Yeah. So 25 plus 96 is going to be our result of what's underneath here. And so in that case, we will have 121. All right, which is lovely because that is a perfect square. So moving on from the previous section here, we have now determined that x is going to equal -5 from this piece here. And then we're going to add and subtract the result of the square root of 121, which we just got down here. And all of that is eventually going to be divided by 2 times 6. So I'm going to write that as 12. So again, a few things happened here. I simplified this underneath the radical part to get 121. This -5 here, I just wrote as -5. And the 2 times 6 became 12. So now what we need to do again is actually find this square root of 121. And so that means that our x is going to equal -5 plus or minus, plus and minus, the square root of 121, which is actually 11. And that will be divided by 12. All right, so that means that we're going to take 2 avenues here. One of them is going to be the end result of -5 plus 11 divided by 12. And the other avenue is going to come from -5 minus 11 divided by 12. And so we're going to take the time to get those 2 answers, because remember that those are going to be the 2 solutions or the 2 coordinates of where the quadratic meets this x-axis. All right, so -5 plus 11 makes 6, and then 6 divided by 12 makes a half. So one of our solutions is a half. The other one is -5 minus 11, and that divided by 12. And so we're going to get -16 that's divided by 12. Those are both even numbers, so if we reduce, we get -4/3. Now, some of you will have made those into decimals, but the idea is the same. So in that case, our solution, or our answer, is that x is going to equal a half, and also x equals -4/3. So that means that as you graph this, you would intercept the axis at a half and -4/3. Let's see, it's positive, so it's going to open up. So it would look like that. Again, this is your one axis of -4/3, and this is your other interception at a half. All right. So that's the first one. And so again, remember when we went over the good and the bad here, this one is probably more complicated and time consuming than just graphing it or factoring it. Okay. But the idea is that it always works and you will get an exact solution. So we'll try another one here. And of course, to start us off, it doesn't actually give us the standard notation. So we are going to have to take this positive x and move it over to the other side of the equals. And so we'll have x squared minus x equals 20. But of course, that is also going to need to move over. So that positive 20 is going to get subtracted. And so our equation becomes x squared minus x minus 20, which will equal 0. And so again, looking at our last example, it was equal to 0 in order to find our a, b, and c. So now I'll take the time to find our a, b, and c. Remember that this comes from ax squared plus bx plus c. And so the c is right here with the -20. The b is this -1. And then the a is the 1 that is out front. So this one out front is your a. The b is this -1. And c is -20. And so now if we plug it into our equation, remember that your equation comes from the song. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, and so then we take the time to plug in each of the pieces. And so we have this empty space right here that's going to be b. Then we're going to add and subtract a b squared minus 4 times the a value times the c value, and over 2 times the a value. Oops, I wasn't going to put that in. Okay. So then if we plug in all of the a's, a is supposed to be 1, so it's going to go here, and then it's also going to go here, replacing that a that I accidentally wrote. Then the b value is going to go here, and then also here, and then the c goes in here. And so remember that we took kind of a side note here and did the inside part to solve. So the first thing that we're going to solve is -1 squared minus 4 times 1 times -20. And so -1 squared, especially if you keep these parentheses, becomes 1. And then we have, again, 2 negatives here. So that means we're going to add 4 times 1 times 20, which is 80. So that means that underneath that square root, we actually have 81. So taking a look at simplifying this a little bit, our x's are going to equal -1. Okay, so a -1 really is a positive 1. And to that, we're going to add and subtract the square root of 81, which is just what we solved for there. And all of that eventually will be divided by 2 times 1, which is just 2. All right. So this is where we solve the square root of 81. And so we know that we have 1 that we will add 9 and divide by 2, but we will also subtract 9 and divide by 2. And so that's where we have our 2 avenues here. One of them will be the answer of 1 plus 9 divided by 2, and the other will be the answer of 1 minus 9 divided by 2. 1 plus 9 is 10, so we're looking at 10 divided by 2, which is 5. And then the other one is 1 minus 9, which is negative 8. And negative 8 over 2 is negative 4. So again, this one you probably could have solved by actually doing factoring, okay? We could have factored this trinomial, but the idea is, again, that this works every time. So our answer or our solution is that x is 5, or intercepts the axis at 5, and then it also intercepts the axis at negative 4. All right. So moving on to kind of that more special part that we've been talking about. So taking a look at this side process that we did of just the part underneath the square root, and then also, again, this piece that's under the square root. It's time consuming and it's important, and it's actually called the discriminant. So the discriminant of a standard form quadratic equation, so again, where the a is next to the x squared and the b is next to the x and so on, is that form that's under the square root of b minus 4ac, b squared minus 4ac. This is the part, again, of the equation under the radical sign. And the radical sign is also known as the square root. We'll just find out later on that there are things called third roots and fourth roots, and so the radical kind of encompasses all of those types of roots. All right, we need to recall that the quadratic equation can have, it turns out, 2 solutions, 1 solutions, or no real solutions. The reason that we use the word real is because there are imaginary solutions, which we will talk about in Algebra 2. And so that is where that word comes from, because later on there will be imaginary ones. And so we don't want to confuse that actually all of them have potentially 2 solutions, just not in the real number world. Okay, so what we're going to do again is use the discriminant to now identify very easily if there are going to be 2, 1, or no solutions. So taking a look at this first statement, they're saying if the discriminant is bigger than 0, the equation has 2 real solutions, and of course D is positive, so D is representing discriminant. Here, if that discriminant equals 0, the equation has 1 real solution because D is 0. And then this last one here, it's saying that if that discriminant is less than 0, meaning the equation has no solutions or it's a negative discriminant, that means that you will not intercept the axis at all. So kind of going through an image of what each of these means. If you have 2 solutions, that's because it looks like this. You've got your 2 intersection points. If you have 1 solution, that's because it looks like this. And so it ended up just touching that x-axis and bouncing back up. And if there were no solutions, that's when it looks kind of like that, where it never actually crosses the axis at all, and so therefore there are no solutions. So again, that was that visual that we had from that graphing section. All right. So we're going to find the discriminant of each of these 3 examples, and that means that we don't actually have to solve the entire equation as we did in the other ones. We're just solving b squared minus 4ac. So we don't need to do the whole thing of plus and minus and any of that. We're just trying to find out, is this number positive, 0, or negative? And therefore we know how many solutions there are. So in order to fill in this form, we need to know that our a value is 3. Our b value is negative 2, and our c value is 2. So plugging it into this piece here, our b value is going to be squared, and we'll subtract our a and our c, 10 to 4. And so the b squared value is negative 2, and then the a value of 3 goes here, and the c value of 2 goes there. Negative 2 squared becomes 4, especially with the parentheses there. And then we have a subtraction of 4 times 3 times 2. So 4 times 3 is 12, times 2 is 24. So we're doing 4 minus 24. And 4 minus 24 is negative 20. Negative 20 is in fact less than 0 or negative. And so because it is negative, there are no solutions. So this is one of those that would have had its entire loop or parabola shape above the x-axis. All right. The next one here, we're doing the same thing, identifying that this is the a value, this is the b value, and this is the c. And we're going to plug it into b squared minus 4ac. So we're going to plug in 11 and 2 and 12. So 11 for the b, 2 for the a, and 12 for the c, leaving us with 121 from 11 squared minus 8 times 12, 96. And so 121 minus 96 makes 25. And 25 is greater than 0 or positive. And so going back to our notes, if this is a positive number, that means there are 2 solutions. So 2 solutions. Now, this is not identifying what they are. We'd have to use the rest of the quadratic equation or formula to do that, but we do know that there will be 2. And then this last one here, same process. Our a is the 1 that's out front of the x squared, b is the 8, and c is 16, and we'll fill it into our b squared minus 4ac. And so we'll put in an 8 for b, 1 for our a value, and 16 for our c value, which leaves us with 64 from 8 squared. And 4 times 1 times 16 makes 64 as well. And so 64 minus 64 is 0, which means that if this equals 0 rather than is less than or greater than, that means that it is no solutions. Oh, sorry, 1 solution. And again, if you don't know, you can always reference, is this number positive, 0, or negative, and therefore does it have 2, 1, or no solution? All right, so that was the 8-9 notes, and so hopefully you can attempt the homework from that. Again, we solved quadratic equations, so the squared equations, by using this formula that we have a song for. And then we determined the number of solutions by using that discriminant, or that piece that was under the square root. All right.